Hello friends, we start with our next topic known as reciprocity theorem. Till date we have completed almost all the theorems, and as I already said, your Thevenin's, Norton's and maximum power, these three theorems are the very important theorem. This is also one important class of theorem in which you will understand few basic concepts, and you will find there are certain problems used to come in examination from this reciprocity theorem. Okay. So if you still have not subscribed, comment and like my channel, please do it. Please subscribe it because it will be more easy for you to go through my all videos, and the link of my all previous videos already mentioned in my description box. So please go through it and try to understand this subject. Okay. So we now start with our next topic known as reciprocity theorem. Reciprocity theorem. Now friends, you will find sometimes there are different kind of questions, or I can say a ticklish type of question used to ask under this theorem. So we will try to understand what is reciprocity theorem and how the concepts are applicable under this theorem. Okay, because you will find there are variety of questions in reciprocity theorem, and you will find it is very interesting to solve those questions. Okay, so we'll see how we'll solve it and what are the different concepts applicable under this theorem. Okay. So the first very important thing is what is reciprocity theorem. So if I consider that this is a network, if I consider friend let this is a network, and say some voltage V is applied here. This is terminal AB. This is your terminal CD, and let's say some current I is present here. So this is your one network. For the timing I will call this network as say network 1. Okay. So what reciprocity theorem states that the ratio of response variable to the excitation variable. Now very important thing, please try to understand. This is your response variable, or you can say this is your response parameter, and this is your excitation variable, or you can say it is your excitation parameter. Okay, I'll call it as excitation variable, and this is your response variable. Okay, so response and excitation means once you apply some voltage, we will call it as an excitation voltage, and against which you will get a response in the network. So if you are applying some excitation at this terminal and you are getting some response at this terminal, so this is your excitation variable and this is your response variable. So reciprocity theorem states that the ratio of response variable to excitation is remain constant. Okay, for time being you write it as variable. Okay, V. So reciprocity theorem states that the ratio of response variable to the excitation variable, if found constant K, under the condition when the position of excitation and response is interchanged. It means if I consider this as my network, say call it as network 2. So again, if this is a voltage V, okay, not voltage V, if I make in this pattern and say this is your current I, okay, again this is AB, the terminal remains same, only you have changed the position of your excitation variable. Okay, so now this is your V, and now the current here is what? Again it is I. So now I will call it as say okay. So now again I have changed the position of V and I. So if I again find, now this is your excitation, okay, and this is your response. These two networks are remain the same network, however the position of excitation and response is changed. Now again you will find the ratio of response to excitation, the ratio of response to excitation. So again you will find the ratio of response to excitation, if again it found to be a constant k, that means you can say that these networks are known as reciprocal networks. These networks are known as reciprocal networks. These networks are known as reciprocal networks. Why? Because if the ratio of response variable to excitation variable remain constant even after changing their position in a network, so you can say that such type of networks are known as reciprocal network, and they are following the concept of reciprocity theorem. So this is all about the reciprocity theorem. Okay, so this response to excitation will be I by V also. Okay, and it is V by I also. It means if it is I by V, then I is your response variable, V is your excitation variable, and if it is V by I, it means V is your response variable and I is your excitation variable. Okay, so if this ratio remain constant even after interchanging their position in the network, then you can say that such networks are reciprocal in nature and they follow the concept of reciprocity theorem. Okay, so this is all about the reciprocity theorem. Now we will first of all we'll see what are the conditions under the reciprocity theorem. So reciprocity theorem is applicable for linear, passive, bilateral, single source. So under these four conditions, it means your network must be linear in nature, it must be passive in nature, it must be bilateral, and it must carry single source. Very important thing. Then only the reciprocity theorem is applicable. Okay, but under what condition reciprocity theorem is not applicable? Yes, you can say it is non-linear in nature. Network is non-linear in nature, reciprocity theorem is not applicable. Okay, I am not talking about passive because yes, active source is required. Here the very important thing, if it is unilateral, it is not applicable. Okay, then if multiple sources, not applicable. Then time varying elements, okay, dependent sources, okay, and if any initial condition exists. So once again see, these are the four conditions for which reciprocity theorem is applicable, but these are the these are say 6 conditions for which reciprocity theorem is not applicable. Why? If network is non-linear, if it is unilateral in nature, if it is having multiple sources, if it is having time varying, if it is having dependent source, if it is having initial condition exist. So now the point is, if there are multiple source, then we are saying that if multiple sources are existing, then reciprocity theorem is directly not applicable. But if multiple sources exist, by applying the concept of superposition, theorem, it is possible to solve, which we have already discussed in our previous videos about the superposition theorem. So if multiple sources are existing, so by applying the concept of superposition theorem, we can easily solve such type of problem. We'll see in our later videos how we'll solve those problems. Okay, so this is all about the reciprocity theorem, and these points are very important. You will find the question based on these points itself in your PSU as well as in your engineering services examination. Okay, so now we understand the concept of reciprocity theorem, how it is applicable in numerical problems. Now friends, we will consider case 1. So these are the two network A and B, and there exists a condition that network A and B are linear, passive, bilateral. So whenever this condition you will find in your problem, so this condition is especially mentioned here to understand that if network is of linear, passive and bilateral in nature, that means somewhere they are asking about the concept of reciprocity theorem. That means these two networks are reciprocal in nature. However, it is not mentioned in the questions. So that's why I am telling you, you have to consider that if the condition of linear passive bilateral element exists and it is somewhere written in your question, so you just try to understand that the network A and B are reciprocal in nature. So as per the condition of reciprocal, if network A and B are reciprocal in nature, so definitely this is your excitation variable, and this is your response variable. So as per theorem, the ratio of I1 upon V1 is equal to what? Again, if this is your excitation variable and this is your response variable, it should be equal to what? That is I2 upon V2. Okay, so you can say that I1 into V2 is equal to I2 into V1. So this is your condition of reciprocity theorem. Okay, means here I1 V2, multiplication of I1 V2 is equal to V1 I2, or you can say from here multiplication of this factor to this factor is equal. Okay, or you can also say this is a constant factor K. This is a constant factor K. Yes, very important thing. Why? Because we have already said that the ratio of this is constant. So I1 upon V1 is K. Similarly, I2 upon V2 is K. Then only you can say the networks are reciprocal in nature. So from here, the very important thing is by directly multiplying V1 to I2 and I1 to V2, you will get this equation, and based on this formula, the problem used to come in the examination. Okay. So this is our case 1. This is our case 1. Now we will talk about the case 2. Now please see. So once again, in case 1, one more important thing is, generally what will happen, it is mentioned that the value of V1 and V2 is given. Either I1 you have to find or I2 you have to find. So in case 1 we have seen the direction of I1 and I2 are in the same direction. Both the currents are downward in nature. Okay, the direction of the current is downward in nature. Very important thing. So here whatever the value of I1, I2, it is positive in nature. Okay, by applying this formula. If we will talk about case 2, now try to understand about case 2. In case 2, if I change this direction, now please see, I am going to change this direction. Get changed. I just changed this direction. So now instead of I2 flowing in this manner, now it is flowing in this manner. I have just changed. So please keep in mind, whenever the direction of I1 and I2 is opposite to each other, either you have to find the value of I1 or you have to find the value of I2. The current will be negative in nature. Okay, so if we have to find the value of I2, say we'll see the questions also. So just keep in your mind, if the direction of the current is opposite to each other, then either I1 or I2, the value comes to be what? Negative. Very important thing. Okay, so this was our case 2. In case 1 we have seen both the direction of current downwards, but in case 2 the direction of the currents are opposite, so the value of current comes to be negative in nature. Okay, so this is our case 1 and case 2. Now we will see few problems. In reciprocity we will more try to understand this theorem through solving problems. Okay. Now friends, this is your problem first. Okay, this is your problem first, in which you have to find the value of I1. The condition is given as network A and B are linear, passive, bilateral network. Okay, so whenever such condition is given, as I already mentioned, please try to understand that the concept of reciprocity theorem is applicable. That means the networks are reciprocal in nature. So if this condition is existing, then only you can find the value of I1. So as I said, just by simply multiplying these factors, that is V1 into I2 is equal to I1 into V2. So value of V1 is 10 into the value of I2 is 2. That is equal to, you have to find the value of I1 and the value of V2 is 20. So you can say the value of I1 comes to be 1 ampere. As the direction of the current both are in downwards direction, it is positive. So just keep in mind, either it is downward or it is upward. Okay, so under this condition I1 is 1 ampere, here also I1 is 1 ampere. Just this is a condition. However, if it is in this manner, okay, if it is in this manner, again both are the different condition and the direction of currents are opposite to each other. Under this condition I1 comes to be minus 1 ampere and here also I1 comes to be minus 1 ampere. Please keep in mind, very important concept. Okay, you will get options like, here it is 1 ampere, then minus 1, minus 2, then 2 ampere. So this is your correct answer in case when the direction of the current is opposite under this situation. Okay, and similarly A, B, C, D, this is say 2 ampere, minus 2 ampere, 1 ampere, minus 1 ampere. So under this condition your correct answer is C, under this condition. Okay, so whenever the direction of current both are in either upward or downward, the value comes to be positive, and when it is interchanged, the value comes to be negative. So this is all about the reciprocity theorem with our first problem. Now we will see the next problem. Okay, now friends, this is your problem in which you have to find the value of I. Okay, and this is an IES problem. It was asked in engineering services, in which you have to find the value of I. Okay, and again the condition is mentioned as network A and B are linear, passive, bilateral. So as I said, whenever such condition you will find, just try to put in your mind, yes, the networks are in reciprocal in nature. Okay, so now in this type of question, see, I'm going to explain you, maybe you'll feel that the process is somewhat lengthy, but it is just to explain you how we'll find. Once you understand the concept, now it will be very easy for you to find out the solution. Okay, so don't think that the process is very elaborative. It is just to explain you how we'll find the value of I in such type of problems. Okay, the first very important thing is, if you find such type of problem, so please keep in mind, whatever the value of IV, whatever we have to find in the network, this is our network which is now different, and this is our network which is now different. Okay, so with the help of this network we will find the condition of this network. Okay, so whenever you have to find the value of current I with the help of this network, so can I convert this network into in this form, these two as terminal as A and B. So if I look towards terminal AB in this direction, so can I find the Norton's equivalent? Yes. Now you ask, why Norton equivalent? Why not Thevenin's equivalent? Yes, Thevenin's equivalent is also you can able to find. Both is applicable. Here I can redraw it as RTH also and this as VTH also, and again this is your AB terminal with 1 ohm resistance and the current flowing is I. So this is your condition 1 and this is your condition 2. So Yes, you can find Norton's equivalent also, or you can find Thevenin's equivalent also, but always keep in mind Norton's and Thevenin's depending up the concept of Norton's and Thevenin's basically depend upon the network with which we have to find the value of I or V in the given network. So how it is? Now see, when why I have talk about first Norton and then I talk about the Thevenin's. The reason is, if you see this network, please see this network. Whenever you find the short circuit branch, okay, here is a short circuit branch. This is your 5 ampere and this is your network A, and this is your short circuit branch. So whenever we find a short circuit branch, why I am saying that? Because as per our concept, if we interchange the position, the ratio of excitation variable will remain same. So if you see, if I interchange this comes to be a short circuit branch. So whenever you find a short circuit branch here, simply apply the concept of Norton's. Why? Because we have to find the short circuit current, and short circuit current will find when the two branches are short circuited. So it will be more easy for us to find out that condition. And if you find an open circuit voltage present here, so simply apply the concept of Thevenin's theorem. So now it is short circuited, that's why I have taken a concept of Norton's theorem. If it is an open circuit, then I will take a concept of Thevenin's theorem. So we will see that problem also, ki when there is a open circuit voltage appearing across these two terminals, in that condition how we will find the value of I and V, whatever it is given in the network. Okay, so from here, yes, I can say that I am applying the concept of Norton's. We'll just remove this. Okay, and this is your terminal B. Now please try to understand how we'll solve this network. Okay, so as I said, we have to find Rn and In, and once you able to find Rn and In for this network, you can easily able to solve this problem. Okay, so from this network, now see, from this network I am redrawing this network. So this network is somewhat like this. Okay, so when we will find, if this is your terminal A and B, okay, this is your network B. So whenever we find the Norton's current, we just short circuited this branch and say it is In. Yes. So for this network, if I have to find a short circuit, simply we have to short circuit the branch AB with this as voltage present 30 volt, that is your independent sources will remain as it is in the network. So this is your condition. So if I say this is A, this is B, or you can say it is A dash, B dash, so I call it as C dash. This is your network C dash. Similarly, if I redraw this network as D dash, okay, it is now D dash. Now please see, D dash, it means is a network in which now we are finding our Norton's resistance Rn. So as per our condition, when you have to find the Norton resistance, your all independent source goes off. So since here it is a voltage source, it is get short circuited. Okay, so now forget about this network. This network we have converted into two form. One is In, another one is Rn. This is your terminal AB. Now if you know the value of In and Rn, one can easily find the value of I for this network, and that is your answer. Okay, now for finding out the value of these two, you have to follow this network. Okay, you have to simply follow this network, then only you can able to find the value of In and Rn. See, just try to understand this concept, very important concept. Little bit it is difficult, but just by understanding how I am finding, it will be very easy for you to solve any type of problem coming under this category. Okay, so this is your C dash and this is your D dash. So now our task is to find the value of In first. Okay, and then we have to find the value of this Rn. Okay, so now question is how we find the value of In. If you compare these two networks, as I said, this is network B, this is network A. Networks are reciprocal in nature. Networks are reciprocal in nature. So the concept of reciprocity is applicable here. Yes. So you can say that the ratio of 2 upon 10, the ratio of 2 upon 10 is equal to what? The ratio of IN upon 30. Yes. By the concept of reciprocity. So from here the value of IN comes to be 6 ampere. Can I say? Yes. The value of IN comes to be 6 ampere. So here the value of IN is here is what? 6 ampere. Very simple. Please try to understand these two networks. Network A and B are reciprocal in nature. Very important thing. Why? Because this condition is already mentioned. So simply I just apply the concept of reciprocity, that is ratio of response to excitation, and I have just find the value of IN. So you get the value of IN. Now next task is to find the value of Rn. Now please see how we find the value of Rn. For finding out the value of Rn, now you see this is your short circuit branch. Okay. So if you see these two networks, do you think what should be the value of Rn here? What should be the value of this resistance so that this condition is satisfied? Okay, just try to understand what should be the resistance across this terminal. So this is known as basically a port resistance. We call it as port resistance. Okay, and this port resistance is basically your Norton resistance looking at this terminal. If I make this network in this manner, since A and B are reciprocal in nature, so what should be the value of voltage and current I have to apply so that this condition should be satisfied? The only condition is if one can able to find the value of Rn. So you can say that the value of Rn is what? Rn is what? That is V by I, or you can say 10 by 5. That is the resistance which is looking from this terminal. So that comes to be how much? It is 2 ohm. So you can say that the value of Rn comes to be what? It is 2 ohm. So once you find the value of Rn and IN, now you can easily find the value of I. Okay. So now the value of I, we can apply a concept of current division. So I is equal to this current is equal to what? Your main current, that is IN, into, you have to find current in this branch. So you have to take an opposite branch, that is resistance Rn, that is 2 ohm upon 2 plus of 1. IN is 6. So this is the value of I. The value of I comes to be how much? It is 4 ampere. Very important thing. This is your final value of I. Okay. So just by applying the concept of reciprocity, one can able to find the value of I. It is not difficult, only just to try to understand this concept. Very important. We move on with the next problem. Okay friends, this is our next problem. Again, the networks are linear, passive and bilateral in nature. You have to find the value of I. Okay, you have to find the value of I. Now, in this question, as I said earlier, in previous question there was a short circuit branch. Now here is a open circuit branch in which voltage appearing, that is plus 20 volt, is given. Okay, so as I said, say this is your network A, this is your network B. So you have to find the value of I in network B with the help of network A. So simply what you will do, you will just consider here two terminal as A and B, and since it is an open circuit voltage, what we will do, we will find the Thevenin's equivalent. So if I redraw this network, this is the Thevenin's equivalent. This is your terminal AB, this is 5 ohm. Say this is the voltage resistance RTH, and this is your voltage VTH. So once you know the value of RTH and VTH, you can find the value of I. So now this circuit is now this network is converted into two forms. See, either this is your terminal AB, So in first case we have to find VTH, okay, and your current source remains as it is as per the condition. This is if this is A, B, say this is network C, or you can say it is A dash, B dash, so it is C dash. Similarly, one more condition we will draw here. This is your network N. This will get open circuited, and this is your resistance is known as RTH. Again it is AB. So call it as D dash. So now this network is converted into two forms, C dash and D dash, just to find the value of VTH and RTH. Now what you have to do, you have to simply compare this network with this network in both the condition and find the value of VTH. Since network are linear, passive and bilateral in nature, one can apply the concept of reciprocity theorem and find the value. Now you see, this is your excitation variable and here it is in a response variable. Similarly, this is your excitation variable and this is your response variable. Okay, so this is a method in which you can find this value. How? See, if I say the value, the ratio of response to excitation, so what it is? 20/2 V by I. This is your response, this is your response R, and this is your excitation E. So ratio of response to excitation, that is 20/2 is what? Is what? Here it is VTH by 4. Yes. So the value of VTH comes to be how much? It is 40 volt. Very simple. The value of VTH comes to be how much? This is 40 volt. Okay. Similarly, when we have to find the value of RTH, as I said earlier, you have to find RTH when this is open circuited. Now you compare these two network. So this is an open circuit. Similarly, like this. So the condition of RTH, if one can able to find RTH here, so these two condition will be satisfied, and that RTH is basically the port resistance looking from here. Okay. We call it as port resistance. What it is basically? This is a port resistance. So what is port resistance? In this condition, if you find the port resistance, or you can say the value of RTH is what? It is 10/2, or that comes to be 5 ohm. Very simple. The value of RTH comes to be 5 ohm. So once you know the value of RTH, VTH and this 5 ohm, what is I? I is equal to the voltage, that is VTH divided by RTH plus of 5 ohm. So that comes to be 40 divided by 5 plus 5. So that comes to be 4 ampere. So the value of your I comes to be how much? It is 4 ampere. So this is your answer. Okay. So I think now you understand how we apply Norton's in our previous question, in previous problem, and how we apply Thevenin's in this problem. Okay, now we go on with the next problem. Okay, now friends, this is your next problem. In this problem you have to find the value of X, and it is given that the network N is reciprocal in nature. So now this is your figure A, this is your figure B. So these are the two figures in which the networks are reciprocal in nature, and you have to find the value of Ix. Okay. Now this is a next class of problem in which we will understand. As I said earlier, in reciprocity it is only applicable for single type of sources, but when multiple sources are there, when multiple sources used to come, we will simply apply the concept of superposition to find out the value of Ix, okay, or the value of Vx, whatever we have to find. So what I will do from figure B, now just try to understand. I can convert this network into two parts. This is N, okay. So friends, what I will do, I will divide these two networks in two parts. Say this is C and this is D. What I will do, first I have considered this 10 volt source. Since we are applying superposition theorem, so since there is a voltage source, gets short circuited. So the current because of 10 volt source, I write it as Ix 10 volt. Similarly, in the second condition, we'll just short circuit this source and we'll find the current because of 20 volt source. So now it is Ix 20. So you can say that your final value of Ix is what? It is because of 10 volt source and because of 20 volt source. Yes, you can say that the value of Ix is what? It's because of 10 volt source and because of 20 volt source. Now our task is to find the value of Ix10 and Ix20, and one can find the value of your final Ix. Now how you will find, please see. Now this is your C and D. Now forget about this network. Now what we will do, we will compare these two networks one by one with this. Okay. So now you see, if again these networks are N, so that means the networks are reciprocal in nature. So here what is the condition? Now the point is, what is the condition and how we will find the value of Ix. Okay, how we will find the value of Ix. Now here one very important concept I am going to introduce, known as homogeneity. Now this is another new thing known as homogeneity. Okay, now you will ask, what is this? What is this term coming here known as homogeneity? So we will see, homogeneity states that if the networks are linear, passive and bilateral and following the concept of reciprocity, then if you scaled the value of voltage and current in such type of network, their ratio will remain as it is. And this concept is just to understand how we resolve those networks with the basics of homogeneity. Now if I apply this homogeneity in this network to make this network similar in nature, so for making this as homogeneous in nature, what I will do, I will multiply this factor by 2. So this 4 is also got multiplied by 2 and this 1 will also get multiplied by 2. So this will become 10 volt, this will become 8 ampere and this will become 2 ampere. So I can say that now the current flowing here is 2 ampere, here it is 8 ampere and the voltage is now what? 10 volt, just by scaling that factor. And now if you compare these two networks, it is of similar nature. It is of similar nature and the direction of 8 ampere is flowing in the direction where the Ix 10 volt is flowing. So can you say that the value of Ix 10 volt is basically 8 ampere? Yes, this is our first condition. Okay. So simply I have applied the homogeneity concept and will find the value of Ix because of 10 volt battery. Okay. So I think you understand how we have find the value of Ix as 10 volt. Okay. Now in next we will find the value of Ix because of 20 volt. So this is all about homogeneity. So I write here as the value of Ix 10 volt is 8 ampere. Now for finding out the value of Ix20, please see, again I am multiplying this factor by 4, this is by 4, this is by 4. So I am directly drawing this network here. This comes to be, this is 20 volt. Okay, here is the current 16 ampere. This is network N and here is the current, this current is 4 ampere. Okay, I have just converted. Now should I redraw this network by interchanging? Yes. So if I interchange it, now this is the condition, please see, this is 4 ampere and this is your 20 volt and this is your 16 ampere current. This is N. Now if you compare these two, if you compare these two, can you able to find the value of Ix20? Yes. the value of Ix20 just by comparing this network, this and this. So you will get the value of Ix20, and the value of Ix20 comes to be how much? Because of 20 volt source is minus 4 ampere. The value of Ix comes to be minus 4 ampere. Why? Because Ix is flowing in this manner and 4 ampere current is flowing in this manner. So your value of Ix comes to be how much? Minus 4 ampere. So once you get the value of Ix20, so your value of Ix finally comes to be how much? It is 8 minus of 4, that comes to be 4 ampere. This is the final answer. This is your final answer. Okay, this is your final answer. The value of Ix is 4 ampere. So in this question we just understand when multiple sources are present, how we'll find the value of Ix, or if voltage have to find, then we also find that voltage also. Okay, so with this problem is finished. We go for the next problem. This is a question, again this is a type of question in which it is given that V alpha is reduced by 8%. So you have to find the value of V1, I2 and P3. Now please see this question. Again this network N is linear passive bilateral network. Okay, so please keep in mind, whenever in such type of network, if voltage and current is reduced by some factor, then the corresponding voltage and current will be reduced in the entire network, as we have already seen in our previous problem. So in this question, if V alpha is reduced by 8%, what will be the effect on V1, I2 and P3? So as I said, your voltage current will either reduced by the same percent or will increase by the same percent. So here if V alpha is reduced by 8%, that means V1 and I2 will also get reduced by 8%. Very simple. Your V1 and I2 will also get reduced by 8%. But if you talk about P3, P3 is the power. P3 is what? P3 is the power, or you can say power is I square. If I3 is the current flowing here, so it is I square R3 into R3. Yes, you can say. So since here power is the square function of current, so you have to find the percentage change in the power. Okay, as we said, when we are reducing V alpha, so yes, V1 I2 also get reduced, but how power will be reduced, or how power will be changed, that we have to find with the help of this function. Okay, so as I said, when V1 and when V alpha is reduced, so V1 I2 is reduced, so definitely I3 also get reduced. So your I3, your current I3 will also get reduced by 8%. Yes, your I3 will also get reduced by 8%. So you can say that your I3 new will be what? It is your I3 minus of 8% of I3. Your I3 is reduced by 8%, that's why your new current is coming. So what it is? It is I3, or you can say 1 minus of 0.08, or you can say it is 0.92 I3. Yes, this is your what? 0.92. So your new current I3 new is what? It is 0.92 of I3. Now similarly in this case you can find the new power, that is P3 new is what? This current, that is I3 new square into R3. So that comes to be 0.92 square into I3 new square into R3. Or you can say it is how much? It is what is the square of 0.92? That comes to be 0.846 I3 square new into R3. So this is P3 new, or you can say P3 new is equal to 0.846 P3. Yes, should we say like that? Your new power P3 new is equal to what? That is 0.846 into P3. So if you have to find the percentage change in the power, so that comes to be what? It is your actual power P3, okay, minus your new power, that is P3 new, and divided by P3. This value is in percentage. So what is P3? Is remain P3 minus of what is your P3 new? It is 0.846 of P3 divided by P3. So that comes to be how much? It comes to be 0.1536, or you can say it is 15.36%. So you can say that your new power will be reduced by 15.36%. Okay. So from here, once again I will write it as, if V alpha is reduced by 8%, so your V1, I2, I3 get reduced by 8%, and your P3 get reduced by 15.36%. Okay, this is one important thing. So this type of question also used to come in your examination. Okay, so this is all about the problems under reciprocity theorem.